So hey guys, in this video we're gonna talk about remote controls for the DJI Inspire 1 or Inspire 1 Pro and Phantom 3 remote, which are pretty similar. There are differences between them, so we're gonna talk about them. We're gonna take some measurements of the antenna outputs. I'm gonna explain why do we have two antennas. They actually want each one for a different purpose. One is transmitter, one is receiver, so I'm gonna talk about that. Also on this modified controller, we're gonna talk about we're gonna try different antennas, compare aftermarket antennas to the stock ones. We're gonna look at the output on the original antennas and aftermarket and see if it's even worth of upgrading and doing a mod, and what are the differences, if there are any. Also, we're gonna test out the Inspire 1 drone antennas and see what there are four antennas. Also, they are separated on receiving and transmitting specifically, and I'm gonna show you which ones are for what, and a few other things I'm gonna talk about. So let's begin. So our first test is measuring power output from Phantom 3 controller stock antenna, and we're gonna use this power meter right here to give you numbers. My distance between antenna will be 12 inches, and all the tests in the future I'm going to perform, they're going to be at 12 inches apart between two antennas, so we can get accurate reading between, in comparison on aftermarket antennas versus the stock ones. And I'm going to explain you orientation of antenna, if there's any differences in power. There are actually power loss if you put your antenna at the angle and it's not up and down. I'm going to do a little explanation on that. So our first test at original antennas, and let me tell you this, the power output on a Phantom 3 controller and Inspire 1 controller, the actual power, the transmitting power, are, according to the DJI website, are the same. So these two controllers are same output. They are 20 dBm at the transmitting antenna. So now I'm gonna power up the transmitter. There you go, and the number on the bottom is what we're gonna read. That's the number of power dBm output of the transmitter. So DJI Inspire or Phantom controller puts out minus 13 dBm at 12 inches away from the antennas, right? That's going to be our base number to go from. So when we're going to compare to aftermarket antennas, we're going to know if there's any differences. So 12, let's say 13 dBm is our factory antenna on Inspire 1 or Phantom 3 controllers. So if your antenna on a drone facing up and down, your controller antenna should be facing up and down as well, because if you're changing your polarization on one of the sides, not on both sides, but just one side, you're losing your power. So it's really important to have your antennas on the controller up and down so they match polarization on your drone. So let me show you what happens if your antennas change. So our drone antennas right now up and down, just how they're supposed to be, and our receiver antenna is up and down as well. So let me show you the power loss that happens if you change either one or other side on antenna polarization. So we're showing 12 right now, so let me do 45 degrees right now. This is a 45 degree angle. You drop down to 17, 18, right? Minus 17, minus 18. Let's put about 60 degrees right there. Now you're at minus 27, 28. That's a huge loss. That's cutting your power by far. And what happens if your antenna completely 90 degree difference between your transmitter and the receiver? So if you're putting it horizontally, you're losing your power pretty much completely. I mean, at this point, it's no good. So that's that. So when you're flying, make sure you keep your antennas at same polarization, and that will give you maximum transmitter and receiver antenna. Make sure you guys don't do this or that or this, because that's just bad news. Okay, so now let's talk about your transmitting and receiving sides of your controller. I didn't know that till I got a little deeper into it, and I just want to explain it to all of you so you guys know. So there's two antennas on your controller, same thing on a drone. One is specifically for transmitting, so all your controllers, all your movements of the drone are transmitted from your controller with a left channel antenna, and there is a separate transmitter. So this antenna right here is meant only for transmitting. The right side antenna are only for receiving. So all the communications from drone back to the controller, video, and all the feedback are done by receiving side of your controller. So this antenna talks, this antenna listens. So now we're moving to the Inspire 1 controller, which I did my modification, and I put SMA connectors. Actually, guys, if you want to do the same, you can visit my website as www.dronelink.us. You'll see a link on the bottom of the screen, and click on it, and we do the services. You send us your remote, and we'll put very nice clean work of putting SMA connectors, and then you're free to put any antennas you want. So let's now get measurements off of transmitting side of the controller, and then we'll try receiving side to prove that it's not transmitting. So our meter is connected and it's flashing because nothing happening right now. We're gonna power the remote and we're gonna see what we're gonna see. So our dBm output out of the transmitting side is almost 13 and a half, let's say 14 dBm, right? So if you look at the website, DJI website, you'll see that DJI advertised that this controller is putting out 20 dBm. 20 dBm, that's power out of the antenna. What does that mean? Why are we seeing 14? So 14, that's directly out of the connector without amplification of the antenna. If you add antenna to it, so meaning that the original antenna that we removed, 14 was about 6 dBm, 6 dBi output. So the 14 and 6, that's pretty much 20. But take in consideration that every connection in line is loss. So every time there's a connector, it's a loss of power, and estimated loss of power, and usually SMA connectors are 0.3 dBi. So 1, 2, 3 connections are equals 1 dBi of loss plus a cable. So that puts out, well, this calculation tells me that the original antenna that you see on drones that we removed was supposed to be 5 dBi antenna. So these antennas that I removed from my controller were 5 dBi. So the 14 plus 1 becomes 15 dBm times 5 dBi antenna. It comes out to 20 dBm power output, which lines up with what DJI website tells us about this controller, and that's true. So now we're connected to our receiving side, which I told you that the left side is transmitting and right is receiving. Let me prove you my theory or truth about this controller. So let me power this up and let's look for the numbers. Nothing happens. Flashing meaning it's outside of the range. It's not receiving anything. It's just not receiving anything. So that tells me right there that this is a receiving side and it's not putting out any power at this point. There you go. So on the DJI controllers, we have a left side is transmitter and right side is the receiving side of it. Alright, so now let's try different antennas. We're going to try this remote with a couple different antennas, and we're going to see if it's worth of upgrading your antennas, if it's worth of doing this mod and upgrading from the stock antennas, or let's just keep stock and not worry about it. So here you go. Now we're going to do a test. So from our previous video, we determined that, well, previous part of this video, we determined that stock antennas are about 5 dBi amplification on the radio side, 5 dBi. So what I did is I took this antenna right here, which is a 6. It's about 5.5 or 6 dBi antenna that you can get anywhere online for about, you know, $5 or $6. So pretty much what we're trying to do right now is put same antenna through the SMA output and see if we're gonna get same measurements as to prove our point that this antenna is 5 or 6 dBi. And so we're gonna power our controller up. Our distance between the controller and meter is 12 inches again, and let's see what our numbers are. And the numbers are 15 or 16 dBm. So our previous numbers were about 14 dBm on the original antenna. What is that telling us? That original antenna, just because it was well balanced for this radio and well designed and didn't have a, don't forget guys that there is a loss of connection. So that connector right here that I installed, it's a little bit of loss in your power. So aftermarket 6 dBi antenna, it's 5.5 or 6, it's hard to tell because each site advertises differently, and kind of I figure it's 5.5 or 6. So this antenna is pretty much does almost the same as factory antenna. So we did the test and we determined that the original antenna that comes with the controller, same output as aftermarket 6 dBi antenna. It's a lot smaller, looks cleaner. I mean, it even has a little better performance, just tiny bit slight hair over this antenna. I'm not a believer in putting something huge and big and bulky that you have to carry around and it's always getting stuck or possibility of breaking it off. I don't believe that. So I mean, obviously I'm not gonna stick 9 or 12 dBi antenna in here because it's just huge. It's gonna be on the way, it's gonna be getting in conflict with your iPad holder and everything, and just is it really worth of upgrading? I mean, you're gonna spend money installing connectors or sending it to us or to somebody else or do it yourself. How much are you gaining in here in this configuration? I would say that due to the tests that I did, if you're gonna stick to the Omni directional, it's not worth of upgrading to put something like this on, because it's just it's not very beneficial. I mean, you're not gaining a lot. If you wanted to go directional, any directional antennas, there are a lot of directionals out there. Yes, it's worth it. It's 100% improvement, increase, and it's the range and everything, and I'll explain the differences between Omni and directional. But if you want to stick to something like this, easy and safe, don't waste your time and money, I would say. That's my preference. I mean, I'm not gonna tell you what to do, but I would not do it if I was gonna stay with this. So that's my scoop. So here's our test with directional antenna that I'm using right now. It's gonna be again 12 inches apart, and this is the antenna I'm using. It's a small profile. It's Alpha Networks. You can find them on Amazon or anywhere online for about $24, $25, and they do really well for my test. And you can watch my videos on my long range flights. I do about 2.5 miles with full antenna bars, no signal loss. I mean, I did 30,000 feet. That one shot. You can find my videos on the same channel, and actually this weekend I'm gonna go for a little longer. But these guys right here, they're good quality. I mean, again, I'm not selling them or anything. I'm just saying that I did my test and they work really well for the dollar, for the money that I spent on them. They worked really well. So let's power this up and see what kind of numbers we're gonna get out of it. So power up and let's see what we're getting. So our numbers are about 9 dBm, and that's pretty decent improvement from going from 13, 14, 13, 14, 14ish, going to 9 or 10. That's pretty good improvement, I would say. And so let's talk about directional antennas and how does it work. So what I'm thinking when I'm thinking about antennas, I'm thinking about radio frequency, and light is the same thing. Light that we see is a radio frequency, it's just a different frequency. So think of antenna as a light bulb. Okay, so you have a light bulb right here, and so the light from this antenna, or let's say this light bulb, if we put it right here and power up, the light will go all around 360. That's why they call them omnidirectional. The signal can be spreading out all across, all around 360, all around you. And also the listening of this antenna, when it listens, your receiving antenna is going to listen all around you. So what's the benefits of omnidirectional, which is this guy? Omnidirectional listens all around you, no matter how far they're drawn away from you, or if it's on the left, right side behind you. You're always listening to it. You don't have to worry about being in direction of the drone, pointing out in direction. But at the same time, the omnidirectional antenna listens all around, so it's picking up all the noise from your neighbor's Wi-Fi, or if you're flying in a neighborhood, everybody's radio frequency at 2.4, you're going to be picking it up because antenna listens all around you. If you put directional antenna, which is only broadcasts forward direction, and depending on degree, this guy about 80 degree left and right and 60 up and down, so it's pretty directional. So think of this antenna as the light bulb that you put in a headlight reflector. Like take the headlight, for example, you put a light bulb in there, so the all power goes forward. Also listening power comes from in front of you as well, so the signals and interference and neighbor's Wi-Fi and all the other interferences that's coming from left, right, and the back of you, directional antenna is not going to listen to those things. And well, it's going to listen to them if they're close enough and powerful enough, but it's going to be a lot less of the interference that you're going to pick up. That's one of the benefits of the directional antennas. Another benefit is that within the antenna, let's say for example this antenna and that, and actually these guys are 8 dBi, advertised at 8 dBi. If you take 8 dBi Omni and 8 dBi directional within this testing right here that we do, they kind of come out with approximately kind of similar numbers. It's not, you're not going to see a lot of difference. Where you're going to see the difference is a distance. Think of the light bulb. If you had a light bulb, the light from it will, let's say, go 10 feet. But if you direct all the light in one direction with reflector, the light will go 25 or 30 feet because all the energy are directed in a one path. So that's when the directional antenna comes in for the long range, because even though it's going to be same power is Omni, and you're gonna have to point kind of in the direction of the drone, plus minus, you know, as long as it's kind of in front of you, it does fine. But it's gonna go a lot longer because your energy are all beamed in that one direction. And well, our numbers are still reading in here. My radio is still on, still getting, you know, 9, 10. So we're still, you know, running test. So anyway, so that's the benefits of the directional antenna and Omni antenna, omnidirectional. So if you decide to do the upgrade, and like I said again, you know, if you want to put SMA connectors like I did, You can visit our site. I'll put a link, dronelink.com, dronelink.us. Send us remote. You'll find everything on our webpage, and we'll install those connectors. You do your research, figure out which antennas you want to use, and what are you using it for. If you're just flying around the neighborhood, don't worry about it really. I mean, if you want a better penetration through the trees, through the obstacles, longer range, or whichever the goals you're trying to achieve, then you should. After this video, we're gonna go into the Inspire 1 drone. I'm gonna put the drone on this table, and we're gonna test antennas on the drone. There are actual antennas, they're receiving and transmitting antennas on the drone as well. And there's other couple tricks that I want to tell you about the Inspire 1. Stick around. So anyway, let's get these antennas tested. And let's power this baby up. And it's up. So let's see. So let me tell you right now, because I already did the test, but the legs on the left side of the drone are transmitting. So this guy and that guy are transmitting power. If you look at it right now, I'm putting antenna right next to it. You're reading about, actually hold on, let me lower that and zoom. Here's your transmitting power. So right next to antennas, you're getting pretty good signal, -3 dBm. And same thing, you're gonna see same thing on this leg right here as well. You put it right there, and the numbers are about 3 dBm. The left side of the drone, front and the back, are transmitting antennas. The antennas on the right side of the drone are listening and receiving. So let me zoom this in to that side, but if you get directly next to it, it's -22, so it's pretty much nothing. To that side, but if you get directly next to it, it's -22, so it's pretty much nothing. So that proves the point that left side of the Inspire 1 is transmitting, talking video back to the controller, and right side of the controller is listening, receiving the signal from your controller to your drone, your communication. And here's a moment of truth. So we're gonna measure our power off of the transmitter on the Inspire 1 drone. Inspire 1 drone. So here's my antenna. I disconnected from the leg on the transmitter side, and I plugged my meter into that. And let's power this baby up and see what we get. 14.8, 14.7, 14.5 dBm. That's all I have to say for now. Please like my video if you like it. Visit my website dronelink.us for controller mods, antenna controller mods. Stick around, come back in, I don't know, a couple of weeks, a month, when I have what I'm thinking to do is, just like I did in here, plugging in different connectors, leaving these guys alone, and connecting different antenna within the drone in here somewhere that are more powerful. If these guys are 2.5 dBi, if I can put something 5 or 6 right on the drone on the transmitter side, so your video can stream better to your controller, hey, that's gonna be great if I can make that happen. If not, sorry, but I will work as hard as I can on it, and we'll see you guys in the next video. Thanks for watching.